let's continue with functions and representative functions, but this time using a graph, an XY coordinate system. Let's draw a graph on an XY coordinate system that does not represent a function. Okay, so I do not want it to represent a function. So we already seen that when we're looking at ordered pairs, we needed, if it's not going to be a function, right, we need the same object and domain to go to multiple objects in the range. So I'm going to just create little dots and connect them. So let's say I'm going to focus on 3. By the way, when we look at an XY coordinate system, the horizontal is always a domain, and the vertical is always the range. So that is always the case in any graph you look. Obviously, it doesn't have to be just an algebra here with XY, it could be in any other object. And the only time I saw things reversed was in an accident reconstruction team, and they had to reverse it, and they had to do something with the way they would chalk the street up, and it sort of made sense for them, for their application. But typically, this is the way it's always arranged. So I'm going to focus on 3, and let's just do this. Pretend like I'm doing order pairs. So 3, 4. Now 3 goes to 1, and 3 goes to 4. This is not a function. So now let's just connect it with a picture. It doesn't really matter what the picture is, but I'm going to connect these 2 dots. Let's say I just do something like this. Oh, there. Again, this is not a function. Why? Because look, for at 3, I'm getting a value of 1, and I'm getting the value of 4. So I'm getting the situation. 3, it gives me 1, and 3 also gives me 4. I can stop right here. This is not a function. You can see other things are also doing the same thing. Like 5 is giving me 2 values. As a matter of fact, 0 is the only thing that's giving me 1 value. Everything else is giving me 2 values. So definitely this is not a function. So I can get even more fancy. Let's say if we're over here. Again, all you got to do is do the same thing. Don't want a function? Fine. Just have multiple things mapped to it. So maybe I'll do something like this. And again, I can see here, it's not a problem, but in this little loopy part, little world, I have -4 goes to, looks like 3. And -4 also goes to, looks like 6. And -4 also goes to, looks like 8. So I don't have to look at the rest of the graph. I can see again that this is not a function. Okay? Draw a graph on the XY coordinate system that is not linear and represents a function. So now I don't want it to be a line or linear, but I want it to be a function. Well, tell you what, I'm going to just draw a quadratic. I'm going to make my life really simple, or a quadratic-like function, looking function. And this definitely is a function, right? Every input here, I get exactly 1 output. Input, output. Now, that output is not necessarily unique. So, for example, if I've done this right, I'm going to do it again, but actually, do it one more time and be a little more precise. So, 1, since I said I was going to draw a quadratic, 2 gives me 4. Is just rather small. Okay, and now I've drawn a picture, and this is a function. And I can see that, for example, 1 only gives me 1 object. -1 also gives me 1. Now, notice the things in the range repeat all the time. Like 1 object here gives me the same value if I've chosen this other object. But every object in the domain only gives me 1 output for the range. So, again, 1 gives me 1. Now, -1 also gives me 1, but that's okay. So the range value is not unique, but it's okay. 2 will give me 4, and -2 will give me 4 as well. and so on. But this is a function. Let's do another example here. Draw 3 functions that are considered one-to-one. Okay, if I want to draw a one-to-one function, what must I do? Well, if I compare it to what I just did, so if I can put these two side by side, you'll notice that this is definitely not one-to-one. So, but I want it to be one-to-one. So if I draw a line, for example, that is one-to-one. Okay. About this one, this is also one-to-one. I can even come over here and do this. And I meant to go a little further out. So this is one-to-one. So you can see right here that -3 corresponds to exactly one object. -4, one object. -5, and then you can see that if I keep this going, every time I choose a value here, it goes to one object, and that object is unique. Nothing else goes to it. Same thing here. -3 goes to whatever this value is. 5 goes to the value, but once I choose the value on the range, no other value can map to it. Unlike this one, 4 got mapped to by going from to 2 and also -2, but not here. So all these values here, all these values on the range are unique for all 3 graphs. And this is again a one-to-one. 2 goes to wherever this value is. 3 goes to another particular value, but unique. It's all unique down the road. And again, if I want to draw a function that is not one-to-one, all I have to do is something like that parabola looking thing. So I'm going to draw one that is definitely not one-to-one. It's not a parabola, but and that right now is definitely not one-to-one. Okay, so again, -3. So let's choose a -2 has this particular value, but then there's some other value here that goes directly to it. So it's, oops, I'm not on camera. Sorry about that. Again, I drew this little loopy thing, and this is definitely not one-to-one. Okay, so we'll come back to these graphs in a second. Let's talk about an idea. Is there something visual in a graph that alerts the viewer that a graph represents a function or not? So when you look at these values, this is a function, this is a function, this is a function, that one is a function. So we have 3 graphs here, 4, 5 graphs, and they're all functions. And is there something here that alerts you that it's a function? Can you see that? Well, there is this definition. Just to get to the chase, you might want to stop the video and think about it for a moment and see if you guessed correctly. But there's a thing called a vertical line test. If you can draw a if you can draw any vertical line and it crosses the graph at only one point, then the graph represents a function. So let's test this out. We said this is a line. I'm sorry, this is a function. So what do I mean by this? Imagine picking any line. I don't care which. I'm going over here, pick a line. Boom, I stop right here. Now draw a vertical line and tell me how many places does this line intersect the graph, and the question is once. Draw anything. And you can see no matter what I choose over here, draw my vertical line, and again, it's only intersecting this graph at exactly one point. And it's got to be true for any vertical line I draw. What about here? The same thing. Imagine picking any vertical line, going down, and boom, I only hit the graph once. Over here, draw any vertical line once. Okay. What about, excuse me, these graphs that we said were not functions? Well, you'll notice if I draw this vertical line here, all of a sudden I'm intersecting at more than one point. And it's got to be at only one point. So if there be a function, you must draw any vertical line, and it can only cross the line at one point. Okay, so here obviously we cross 3 points here. If I come over here, I'll cross it 2 points for the majority of these. And yes, here, for example, if I draw and it intersects only once, but the key wording here is any vertical line. You must be able to draw any vertical line. That you could do it once does not make it a function. So again, that's the vertical line test. Okay, and now there's a second one, the horizontal line test. You have a graph that is a one-to-one function. Oh, sorry, you have a graph that is a function. Is that what I want to write down? One second, let me think about this. I forgot what I wanted to write down there. Right. So you have a graph that is a function. That function is also 1, 2, 1. If you can draw any horizontal line and it crosses the graph at exactly 1 point. Okay, so first of all, remind yourself that we already know that this is a function. We established, so it passes the vertical line test. That's not a problem. The question is it one-to-one? And again, it's one-to-one if you can draw a horizontal. Besides passing the vertical line test, you must also pass the horizontal line test, which is the same thing but horizontal. It crosses 1 point. So for example, this one we said draw a function that is not one-to-one. So clearly this is a function. It's passing the vertical line test. But when I go into the horizontal mode, this horizontal line is crossing multiple points. So this is definitely not one-to-one. What about the ones here that we said were one-to-one? Well, again, you can see the same scenario. Now I'm going to start drawing horizontal lines, and you see no matter where I draw it at, it's crossing the graph at exactly 1 point. So this makes it one-to-one. Same thing with this one. Draw horizontal lines, and each time I'm only intersecting at 1 point each time. And so these are one-to-one functions. So visually in a graph, if a function is one-to-one, it will pass the horizontal line test and also the vertical line test. And I should have said that backwards. Notice one thing here, that we have spent a lot of time defining terms and what their meaning is. Algebra attempts to organize concepts that are deemed to be essential and provide names to those concepts. So vocabulary and their meaning are something you should be focusing on in this course. So I know that sometimes this seems strange that we're focusing on these behaviors of graphs, but this is a very important aspect of the course. And again, the beginning of this course, it's all about these general concepts about functions. And that's what we're exploring at the moment.